Hello students, welcome to Microwave Engineering Laboratory, and today's experiment is VSWR measurement of open and short circuit loads. The aim of the experiment is to determine standing wave ratio and reflection coefficient with open and short circuit loads. Coming to the operators, the required operators is microwave source. Source is used to generate the microwave energy. Okay, then isolator, frequency meter, voltage standing wave ratio meter, variable attenuator, slotted line, tunable probe, waveguide stands, movable short or termination. See block diagram. This is what the setup number 1, which is required to do the experiment in laboratory. So initially, detector mount is connected to the slotted section, and by using the detector mount, you have to find out the voltage, otherwise power values, maximum power values. See, microwave source, okay, I mean Klystron power supply. Power supply is connected to the Klystron mount. Klystron mount generates the microwave energy, which is passed towards to the isolator, and isolator acts like a uniline. Whatever the energy reaches to the isolator, it sends only in the one direction, that towards to the variable attenuator side, okay, and variable attenuator to the frequency meter. By rotating the frequency meter, okay, you can set a particular frequency to the microwave energy generated by the Klystron mount. Here the band value start at 8.4 to 12.4. Okay, 8.2 to 12.4. So that is what the band value. Within that, you have to set a particular frequency by using the frequency meter. Frequency meter to the slotted section to detector mount. So this is what the output detector mount. So probe is connected to detector mount to the CRO. So you have to fix the maximum signal strength appears at the CRO screen by rotating the Rippler knob. Okay. After fixing the maximum signal strength, you have to take the power values. So this is what the setup number 1. Okay, let's go to the setup number 2. Setup number 2, see here. So source is connected to the isolated to variable attenuator, frequency meter, slotted section. Up to slotted section, that is what the fixed setup. You need not to change anything for all the experiment. You have to use this one up to slotted section, and from slotted section to SS tuner and matched load. Other side, tunable probe to VSWR meter. Okay, so tunable probe, you can move the tunable probe on a slotted section. By moving the tunable probe, you can fix the maximum signal strength. Okay, other side, there is a SS tuner to matched load. So SS tuner contains the knob. Okay, by rotating the knob, you can fix the maximum or minimum loads. Okay, here for matched load, you have to apply the minimum load. Other setup with a combination of movable short, SS tuner to SS tuner to movable short. This is the another setup. Okay, setup number 3. Here movable short is used for the high VSWR values. Means you have to apply the high load by using the SS tuner. So there is a screw right. So by rotating that, you have to apply the maximum load. Means when you block the energy, whatever the energy reaches to the up to SS tuner and movable short, and that travel towards to the source side. Okay, by moving the tunable probe on a slotted line, you have to take the power values. This is the setup number 3. See, observations. You have to calculate the input voltage. I mean, whatever the voltage you are applying now, that you have to write down input voltage. And by rotating the gun bias knob, you have to fix the beam voltage in between 230 to 250 and the Rippler voltage. By rotating the Rippler knob and in anti-clockwise direction, fix the maximum signal strength appears on the CRO screen. and you have to write down dot voltage, and beam current should not exceed 18 milliamps. See, I am giving some observations here. See, beam voltage 245, beam current 18 milliamps, regular voltage 200 volts. Here there is a minus sign, so it is a regular no traveling in reverse direction, right? That's why I am using the minus sign. So simply it represents the direction, negative direction. And how to find out the maximum voltage using CRO, and that too by connecting the detector mode, and that value is 10 millivolts, and power minus 44.70 dB, and VSWR value is 1.17. So this is the setup number 1 by using the detector mode. When you connect the detector mode to the setup, and you have to find out the power and standing wave ratio. Then go for the high VSWR. So SWR S greater than 10 case. So you have to use the movable short. See, for high VSWR power value, when you connect the movable short to the slotted section with help of SS tuner, the power value is minus 44.07 dB. The standing wave ratio is 4.98. So remember, so it is S greater than 10, right? So there is a knob behind the voltage standing wave ratio meter. Behind there is a knob. So the knob which is made for the low VSWR and high VSWR. So you have to keep the knob for high VSWR, I mean greater than 10. So values start at 1 to again 10 values. That means 10 plus whatever the value you got it. Okay, here it is a 4.98, right? So for S greater than 10 case, it is a 4.98. Okay, if you fix the knob to low, this value might change. Then go for the low VSWR. Yes, less than 10 case, you have to use the match determination. Take off the movable short from the setup and connect the match determination, and you have to check the two cases. One is a low VSWR and medium VSWR. For low VSWR case, so SS tuner depth is high. I mean, you have to release the knob completely. So there is no load at all. I mean, you are not at all applying the load, means whatever the energy reach to up to SS tuner, you are releasing that energy towards to the master determination. Okay, so there is no load applied at the SS tuner case. That is what the low VSWR, and there the power value is minus 54.7 dB and standing wave ratio 1.6. Then go for the medium VSWR. So the depth, apply the medium depth. Okay, don't apply total, just keep it to SS tuner depth to medium. Okay, mid position. Then check it what is the VSWR values. So power is minus 48.2 dB and standing wave ratio is 2.80. Okay, see in previous slide, when you connect the movable short with a combination of SS tuner, here you have to apply the total, you have to apply total load. I mean depth is high, so total. Okay, when you block it totally, what is the standing wave ratio? That is a case. Then go for the low and mid values. So without load, what is the standing wave ratio? And when you apply the medium load, what is the standing wave ratio? That is what we are looking here. See the waveform. So try to find out the maximum voltage and the minimum voltage. When you know the maximum and the minimum voltage, in between how the standing wave is varying. So this is what the waveform. Coming to the Viva questions, the first question is, does voltage standing wave ratio vary with the line of the length? Question number 2, can the magnitude of the reflection coefficient rho be greater than 1? Question number 3, can voltage standing wave ratio be negative? Question number 4, is there a minimum length of transmission line required on either side of the VSWR meter for valid readings? Question number 5, is the characteristic impedance of the sampler line section important? Question number 6, what is an acceptable VSWR, voltage standing wave ratio? Question number 7, define voltage standing wave ratio. Question number 8. Define reflection coefficient. Next one, what is the standing wave? The next question, what is the reflection coefficient? 11th question, when do standing waves form? Question number 12, how they are useful in the microwave engineering, I mean standing waves. And 13, what is minimum value for the voltage standing wave ratio? And last and final question, what is the range of the reflection coefficient? So these are the questions I have raised here. Please try to answer these questions. Let's move to the laboratory. Check the three setups and try to find out the powers as well as the reflection coefficient. And for the medium, low and high, check the three cases and try to find out the note down the observations. Okay, let's move to the laboratory. So after experiment, once again I'll explain the calculations on board. Thank you. Good morning, students. And today's experiment is VSWR measurement of open and short circuit loads. So switch on the cooling fan. Once again, airflow direction should be towards to the klystron mount side. Then after, switch on the power supply, klystron power supply, and make sure beam voltage should be in between 230 to 240 volts. Then take down the corresponding beam current value and it should not exceed the 18 milliamps. Then by rotating the regular knob, fix the maximum signal strength appears on CRO screen. Now initially start with an experiment with the detector mount. Connect the detector mount to the slotted section and find out the power values. And this is what the very first step you have to do in the lab for all experiment. Not only for this one, for all experiment you have to calculate the power by using a detector mount. Step number 2, particularly for this experiment, connect the SS tuner with a combination of a matched termination to the slotted section. And we know by moving the tunable probe on the slotted section, we can find out the minimum and maximum positions, right? I mean D1 and D2 positions, right? So initially check it. So there is a maximum signal when you're moving the slotted section. Tunable probe, this is what the tunable probe on a slotted section, we can change the signal strength. We can see the change of signal strength on a CRO screen. So maximum, minimum, again see minimum and maximum. Like this you have to find out the positions. So take the two successive minimum values, D1 and D2, we can find out the lambda G, guided wavelength lambda G equal to 2 into D2 minus D1. By knowing the lambda G value, we can find out the voltage standing wave ratio, which is equal to lambda G divided by pi into D2 minus D1. Okay, so by knowing the voltage standing wave ratio, we can calculate the reflection coefficient value. Voltage standing wave ratio equal to 1 plus R by 1 minus R. Okay, so we can find out the R value. By knowing the R value, we can find out the impedance. So this is what the flow of experiment, particularly here. So by using the voltage standing wave ratio meter, I'll show you how to find out the standing wave ratio value directly by using this meter. Okay, now see, SS tuner and matched termination is connected to the slotted section, right? Mom, connected to the probe, connected to the standing wave ratio meter. Yeah, see here. Release it. Because you have to apply minimum load, right? Release it. Yeah, see here, the standing wave ratio value is 1.60. Okay, so this is what the step number 1. Now move the SS tuner position to the mid. So you can move it. So move to the mid position, fix it, madam, fix it, and apply the load. See here, yeah, hold on it. See here, standing wave ratio increased up to, when you apply the load, the value is increasing here, increase up to 3. Initially the value was 1.5, but here it reaches to nearly, yeah, it reaches to 3. So standing wave ratio increased at mid position. So the case number 1, low VSWR value, that I have shown 1.5. Then go for the medium or mid value. So at mid position, the voltage standing wave ratio is 2.90. It is a 3. It reaches to 3. Then again you have to calculate the high VSWR value. But I move to this side completely. Yeah, completely. And now apply the load. Yeah, it was the power range, right? So high reflections are traveling towards to the source side. For that it is high VSWR. Backside there is a knob. So you have to switch on the high VSWR range and change the range value. Check it here. And mode also you have to keep it in. Yeah. See the value? So really showing 9.25. Okay. So initially it is a 1.7, and at medium and our mid value it is reaches to up to 3. But if you go for the high VSWR, when you go for the, when you switch on the high VSWR knob, it shows the 9.25. Okay, so these are the 3 steps you have to perform the VSWR measurement of open and short circuit loads. So this is how you have to do. So case 1 low VSWR, case 2 medium VSWR, case 3 high VSWR. So yeah. Okay, thank you so much. Hello students, the practical observations for the today's experiment is VSWR measurement of open and short circuit loads, voltage standing wave ratio measurement of open and short circuit loads. The observations are the practical voltage what we have seen in the laboratory, 240 volts. Beam voltage, beam current is 18 milliamps, and reply voltage is minus 200 volts. Here you have to find out the maximum and minimum voltages using CRO by connecting the detector mount to the slotted section. So after connecting the detector mount, so find out the maximum voltage, that is 10 millivolts, and minimum voltage is 2 millivolts. Okay, and the power is minus 44.70 dB. For that, standing wave ratio 1.77. Okay, remove the connection to CRO and connect that probe to standing wave ratio meter or power meter, and we can calculate the power straight away. The value is 44.70 dB and standing wave ratio 1.77. Here two cases. First, you have to find out the low VSWR and medium VSWR values by using a matched load. Okay. Remove the detector mount to the test bench and connect the matched load with a combination of SS tuner. Okay. Matched load. And back side for the power meter there is a knob. VSWR knob, high and low values. For low VSWR, you have to keep it in low mode. Keep it in low mode. Case 1, find out the low VSWR. For this case, power meter shows the value 54.7 dB, and if you on the SWR mode, then it shows straight away that value is 1.6. Okay, and case 2, move the SS tuner to the mid position and just apply some load, and that case you have to find out the medium VSWR, and that value, power value is minus 48.2 dB and the standing wave ratio is 2.80. So this is true for the matched load, particularly for low VSWR, S value less than 10. If you go for the high VSWR, for matched load you cannot find the values. For that case, remove the matched load from the test bench, connect the movable short to the SS tuner, combination of SS tuner to the slotted section. Then for higher VSWR, again you have to do one more step, that keep the VSWR knob to a high position. So that you can find back side of the power meter, just switch on to the high mode, then it shows the power values 44.07 dB as well as SWR value is 4.98. So here by seeing the 4.98, you feel like it is less than 10, but when you keep it knob for lower mode, it shows like not in range. Okay, so when you switch on the high mode, then you will get the value from 0 to 10 again. So here the value is 4.98. in case of S greater than 10, means 10 plus 4.98, it is a 14.98. that is what the logic here. So this is how you have to find out the VSWR measurement of open and short circuit loads. So SS tuner with a combination of matched load, you have to do the two cases, case 1 low VSWR, case 2 medium VSWR. For high VSWR, you have to connect the movable short with a combination of SS tuner to the test bench, and you have to perform the experiment, and that case will get the value more than the 10, and that value varies. It might be 3, it might be 4, it might be up to 9, means 10 plus that value. Okay, thank you. Yeah, let me draw the picture also. I forgot to draw here. See, so we know the maximum voltage and minimum voltage, no? So voltage standing wave ratio means we are checking the standing waves in the test bench, right? So initially you have to find out the maximum and minimum values. Yeah. Here it is a voltage. And that graph B is standing wave pattern. The maximum value which is 10 millivolts. The minimum voltage is 10 This is how you have to draw the standing wave as well. By finding out the maximum and minimum voltages by using the detector mount. Connect the detector mount to the test bench. Okay. Then after, give the connection, probe connection to the CRO. You can see the signal on the CRO. So take the maximum and minimum voltages. Yeah. So this is what the experiment. Thank you so much.